Question number 61 is standard boiling point of water is. So if we talk about the standard boiling point of water, as per IUPAC recommendation, at 1 bar pressure, the standard boiling point of water is 99.6 degrees Celsius. And that's why the correct answer is option 3. And it's a turn for question number 60.
Question number 62. At constant temperature and pressure, correct order of entropy of gases for their equal moles is. It means in this case, we have to arrange the given gases in the order of their entropy. And we have to choose the correct order. One thing we should always remember that whenever we talk about the entropy, that depends on the atomicity of the gas. So simply we can say more the atomicity, it means more number of atoms are present in the gaseous molecule, more will be the entropy of the gas. And now on the basis of this, if you just want to consider all these given gases. In the first case, all the gases are monoatomic, so all will have the same entropy. In second option, there is helium, then oxygen, then CO2, and then PCl3 is there. In this case, you can clearly see that these are correctly arranged on the basis of increasing atomicity. And definitely in that case, entropy is increased also, so this is the correct order. If we look at third option, in this case, oxygen is also given here and that is having the same entropy as that of neon. This is incorrect. And further, last option, first is oxygen and then ozone, and both of them have same entropy. It is given. This is wrong. So which option is correct? Only second option is the correct one. That's why this would be the answer for this question. After this, let's move on to the next question.
Now question number 63 is here. Standard entropy of A, B, C are 30, 60, 100 joule per Kelvin per mole respectively. For the reaction 2A plus 5B to give you 6C, if the delta H value is 300 kilojoule, then the temperature at which the reaction will become spontaneous is. You should know that for the condition of spontaneity, this delta G value should be negative, or simply it should be less than 0. And we know that this delta G value is equal to delta H minus T delta S. And this value should be less than 0. It means we have to consider this formula here. And further, we have a given reaction, that is 2A plus 5B giving you 6C. And for each of these reactant and product, there is the entropy value which is given. Let's find out the entropy for the reaction. That would be equal to the sum of the entropy for the products minus sum of the entropy change for the reactant. This formula we will follow. So here, the entropy for this particular reaction is equal to 6 into the entropy for C, that's given here 100, minus what would be the entropy of A, that's given here 30, and 2 is the coefficient. That's why I'm multiplying this coefficient here. In the formula, this gamma is representing the coefficient here. Now, there would be 5 into 60. And if you solve this, you will find that this value comes out to be 240 joule Kelvin inverse. So we have the entropy of the reaction. Now we know that this delta H value minus T delta S is less than 0 for the condition of spontaneity. So definitely this delta H should be less than T delta S, or simply if we find out this T value, it should be delta H upon delta S for the reaction. Delta H value we already have. This T should be more than this delta H upon delta S. Delta H value we have. This is 300 kilojoule. Let's change it to joule. Divided by delta S value that we have calculated right now, 240, and from this we can write here that this value is 1250. And this T value should be more than 1250, and where this is given in option 4 only, that is 1260 Kelvin. So this is the correct answer. This temperature is 1250 Kelvin, and the answer for this question is option 4. I hope this question is clear to you. Let's move on to the question number 64.
Question number 64. For a reaction in which calcium carbonate is decomposed to form calcium oxide and CO2, the Kc value is given, that is 0.5 mole per liter. The maximum moles of CO2 gas formed at equilibrium in 5 liter container is. So in this particular case, we have the value of Kc that is given 0.5 mole per liter. This is given in the question. And further, you need to find out the maximum number of moles of carbon dioxide gas which are present in the container, that's volume is 5 liter. We know that the Kc value for this case will be dependent only on carbon dioxide. Why only on carbon dioxide? Because calcium carbonate is in solid state. We will take its active mass as unity. For the calcium oxide is there, active mass is unity again. So it will depend on the active mass of CO2 because it is in gaseous state. And now the Kc value is given. This is 0.5 mole per liter. That's why it should be equal to the active mass of CO2. And how would you calculate it? It would be number of moles divided by the volume in liter. And now the number of moles of CO2, which basically these are the maximum moles of CO2 which are present here, would be 0.5 into 5 mole. These are 2.5 mole. And if it is so, you can easily mark the correct answer, that is option 2. Let me mark here correct answer. And now after this, the question number 65 is here. Question number 65. The KSP of AgCl, AgBr and AgI, the 3 salts are given here, X, Y and Z respectively. On addition of AgNO3 in the equimolar solution of Cl negative, Br negative and I negative ions, AgI first appears as precipitates and followed by silver bromide, then silver chloride. The relation between X, Y and Z is. So basically we just have to consider the 3 salts. One is AgCl, other is AgBr and then we have AgI. And in this case, this X, Y and Z are the KSP values for all these salts respectively. Now, on addition of AgNO3 in the equimolar solution of chloride, bromide and iodide ions, AgI first appears as precipitate followed by AgBr. It means first you will obtain the precipitate of AgI, then AgBr, and then we'll obtain the precipitate of AgCl. So this is the order in which you will find out the precipitate. And now you should always remember that whenever we talk about the formation of precipitate, the salt with less KSP value will be obtained as PPT first. And if it is so, then the salt that AgI is obtained as precipitate first will have the least value of KSP. It means Z is the least one. Then AgBr is obtained as precipitate. It means its KSP value is more than Z but less than X. So in that case, here would be Y and then X. Now this is the order of the KSP values, and that's why the relation between X, Y and Z is clearly given in option 3, where the value of X is maximum while the value of Z is minimum. So you can easily write here the correct answer. That's option 3. Now after this, it is the turn for next question.